Morgan,
need
do
to
you
do
want
anything
to?
with the
I've
recording?
just started a recording, a new recording. If you want to just introduce what this is.
Excellent. Okay. So hi, I'm Morgan. I'm going to be talking about Git and using it with GitHub today. Source control, and source control is very useful, but nowadays it's also the main way you sort of socially interact with open source is by going online and using one of these source control repositories in the sky, in the cloud, kind of a thing. So who am I? I'm Morgan. I work on open source for IBM. I use Git every day. I used Git a lot before that. I've done several different Git classes on sort of the details of using all the different Git commands, and this is mainly going to be focused on using Git with GitHub, hence the title. Is that good for an intro?
Excellent.
Also, I can't really see the chat, obviously, as I'm presenting. So if there's any questions, please.
Yeah, I'll warn you if there's any questions.
Okay, super. So as I said, this is accelerated sort of basics of how to use Git. I'm going to skip a lot of the details. I'm going to throw some terminology at you just so that we and try to revisit it during the time. But I'm not going to focus on. I'm not going to go through sort of in depth all the different commands. I'm going to focus on these are the ones that you need to use day to day to get through making a pull request, and that's what you basically do when you're interacting with GitHub or some of the other forges, Bitbucket, GitLab. There's not a lot of beyond certain specific projects like the Linux kernel, there's not as many projects that do these sort of, I'm going to send patches around through email. A lot of the ease of use is brought by using something like GitHub. But hopefully there are enough people on here that don't have a GitHub account, but we're going to go through setting up a GitHub account, which is pretty easy. It's just another email and password kind of a situation. For those of you at IBM, there's some IBM specific stuff that we'd like you to do. I'll try to go through that very quickly so that people don't get bored. We're going to set up your Git CLI. So Git is primarily a sort of a command line based thing. There's lots of different GUI, graphical UI interfaces that are available on different text editors, VS Code, Eclipse. Those are all different and they all work slightly differently, and they all have slightly different user experiences. So I'm going to focus on using this in the terminal, and hopefully you have some terminal experience. I tried to make this vague enough that people even on Windows should be able to try and do some of this, but we're going to skip the more Linuxy, Unixy specific, Mac OS kind of specific stuff. And so again, we're going to do pull request workflow. What it is, it's basically applying Git knowledge directly, and we're going to sort of ignore a lot of the background noise of, oh yeah, there's SHA-1s and commit blobs and all that. Throughout, we're going to have some terminal demonstrations I'm going to be typing. I'm hoping you guys can type along and give me some feedback so that I don't go too fast, but I do know that I only have a certain amount of time, so I'm going to have to kind of continue to move forward at a regular pace so that we don't, so that we finish. So this is just an amusing comic that I like that I think is credited at the top, but I'll have to fix that if it's not. Basically, it says, oh yeah, this is Git. I don't know how to use it. Basically, if you get enough errors, you just copy the folder over, delete everything, and start over. And for a long time there, that was definitely, that definitely does seem to be sort of the default way people end up failing to use Git, and they just go, oh, you know what, I'm just going to start over and clone a fresh copy, and then it'll work. And that's, that's close to being a good way to think of Git, but hopefully by the end of this, we'll be able to fix that without getting stuck. We'll be able to sort of download and freshen our copy without needing to delete everything. So now that I've explained the joke and it's dead, we can move on. There's lots of material online. This slide is in the slides. And some of the stuff that I just want to point out is this gitscm.com seems to be the sort of the central place where people talk about Git and Git is developed. And the book that they have is very good in terms of, it's got lots of nice pictures and it goes through lots of scenarios. It's a bit more, it's obviously a bit more generic in that it covers all of Git, but it's a very good resource. It's got, again, good pictures. I've snatched a couple and put them in here. Then one of the new things that I really like to point people at is this GitHub Learning Lab, and it's again focused on using Git with GitHub, but it's sort of an automated way of where they walk you through. Oh yeah, here's creating a repository. Here's how you interact with the repository, and then you go and you set up. You have access now. You set up. You have SSH now, or you have HTTP now, and then eventually they have you push things, and they ask you to push specific stuff, make a PR, and sort of automated of what version of what we're going to do today. We've got some more resources, and then at the bottom there's this command, which I'm not going to cover the command, but a lot of people who are more advanced users of other source control systems or things like Garrett, where there's a process, but you can do the entire process from the command line. They don't like going into the web browser and clicking create pull request. So this hub command at the bottom here will let you go through the entire process and not ever leave the command line and handle making PRs and everything you can do in the web browser from the command line. Okay, so what is Git? Again, source control. It's at this point probably one of the more widely deployed and publicly used ones. I know there's a lot of private repositories that are enormous behind the scenes, at least in IBM, and I'm aware of some that exist in similar places, Google and Microsoft, that they have giant repositories and custom code to support them. But out in the open source world, Git is kind of the big one. There's several different websites that have sort of social interactions around their Git repositories, and GitHub is probably the biggest one of those, and the most widely heard. You'll see some others like SourceForge and GitLab and Bitbucket. And the biggest thing, it's not new anymore, but the biggest thing at the time was sort of the distributed version control. And so what does that mean? That means that it's unlike SVN, where there's a server that has all the versions on it, and then you basically ask for a version and it plops it down locally on your disk. With Git, you kind of have everything available locally that existed at the time that you did your initial contact to the server, your initial clone. And so the initial clone makes a copy of everything, and for large projects it can take quite a while. Kubernetes is huge, and so it takes, it's got like a gig of stuff that it comes down. But once you do that, you can go back to sort of V001 and look at the repository in that state, and then you go to any other state. And so this is a very useful technology, because it allows you to look at the history of a repository. And so if you have a question, well, how did this get in here? You can actually you can check out the version that you can figure out the version that it came from, and then you can go check that version out, and you can see, okay, here's the exact change that was made. And you can do that locally, totally disconnected from the internet. But there is a drawback to this in that I know RTC has sort of automated syncing with the server, but this requires sort of manual. You have to either get your patches from another person in terms of connecting to their computer, or they send you the patch, or in terms of GitHub, you have to manually sync with the repository in the cloud and download everything periodically, and mostly manually. Some people set it up to automatically do a fetch, but you can get in some amount of trouble doing that. And like I said, big feature is cheap branching. So not only can you check out previous copies of the various branches, but you can move from branch to branch very, very quickly and easily. And so this leads to basically everybody should be working in a branch at all times. You shouldn't work on the trunk of the code that everybody's merging into, but you should work on your own side root, side branch, do all your work, finish it up, merge it back in at the end. And the mechanism to do that in GitHub is to sort of make a PR and have people review it and come back, and at the end it merges. So everything in Git is sort of referred to by these big, long, nasty looking strings, and they're basically the hashes of the content. And so a lot of time I'll say, tree-ish, SHA-ish, hash-ish, basically just saying, okay, this is a reference to that specific thing. Everything that is stored and tracked by Git has one of these, but the main one we're concerned with on a day-to-day basis is basically the commit level, which is just a data structure that holds all the sort of current, not current, but it holds all the pointers to all the different files, and say, okay, well, this is this specific file, this is this specific file, this is this specific file, and that is wrapped up into a commit, and then we point at commits and we say, oh yes, this commit is the details of the repository at a point in time, and usually you're at the top, you're on the top of the tree, and so it's always the current point in time. But again, you can go back, you can go sideways and work on many different things at the same time. Git is basically a dumb file manager. So beyond the sort of standard file access control, you don't have any concept of users or not being able to do something, or being able to operate on only some specific subset of a repository set of files. So that's kind of a big drawback, because you have to sort of wrap Git in something else to control access. So the default Git repo, basically, if it's exposed on the internet, anybody can push and pull to it. It takes access control around that through SSH or GitHub or something else to actually control it. Git is spelled GIT, and a lot of people make the typo of GET, because I guess get, but I just want to make sure everybody's on the same page with that. So it's just some quick terms. I'm going to say these things over and over again, and I just want to make sure we're all sort of specific about what we mean when we say them. The repository is basically all the files that are being managed, and not just the files, but the history for all of the files, which is tracked in a hidden .git directory. And so, when I say local repository, that's basically that on your computer. And then when I say remote repository, that's that on a computer that you're not on. And so, I've got a local repository of my particular project, and then there's a remote repository on GitHub. But there's also sort of a remote repository in a second on your computer, and the person next to you's computer, and the guy in Antarctica's computer, and those are all different manifestations of the same project, but they're all repositories. So commit, we kind of already described before. It's sort of this hashed blob, that data structure that contains the metadata about the different changes to files, and you can point at it and say, this is the commit we're working on, and that would be a branch. And branch, at least in Git world, is nothing but another pointer to a commit. And so you can check out a branch by doing whatever the commit says to put the files on disk. Cloning, so that's what to do to make a copy of a repository. So when we clone the remote repository, we get a local repository. And next term would be remote, and you're gonna have to manage. This is something I don't interact with on a daily basis, other than I know I'm talking to the GitHub remote, but otherwise most of the time I don't interact with remotes. Some people like to add everybody else's forks from GitHub into their sort of remote list so they can look at somebody else's changes. And that's a good thing to do, is if you're collaborating with somebody, is be able to look at your collaborators' changes. Fetching is the term we use to say just copying down from the remote. This doesn't actually apply the changes for the most part. You still have to check out the change once you've pulled them. So you can have different branches, which is again a different sort of history of changes that are being done outside of the main branch. And then pushing would be, we're sending our commits up to a server. Okay, so what is GitHub? It's sort of the centralized part of decentralized. This is a public place where people host their Git repositories. There are also enterprise versions and private repositories available. And basically what GitHub provides is sort of the social interaction, because you have accounts, along with a pretty UI on the web for doing interactions with Git. You can do most things just in the web browser now, including edit files and create commits. But beyond interacting with Git, what you get around that is issues and pull requests, and this is sort of your project management space where you can create boards, assign people to specific issues, assign people to review specific pull requests, all of that sort of social interaction. Along with that, you get metrics. So GitHub is tracking how many people are looking at your project, and you can get an idea from that as a wiki. But there's many other things that I'm skipping, but these are some of the big important ones. And then GitHub also provides interaction with external services, and the primary use for that is, oh, here, run my tests when I make a push. So like I said, social, so you need an account, and this lets you talk with other people and let other people talk to you. You collaborate, you work together, and GitHub, having these accounts allows GitHub to provide the access control that Git doesn't have. So I mentioned earlier that Git's just concerned with files, while GitHub is concerned with people, and this allows sort of open source projects, which are everybody can copy. It allows sort of restrictions on who can push code directly to the sort of the maintainers to merge and push directly, but it allows everybody with an account to make a pull request and get things merged using the system. And then once you have a project, sometimes you want to have a website for your project, and you want to have storage for your artifacts, and so GitHub provides that. GitHub Enterprise, we have an internal one. I'm sure lots of other people do. And we'll skip the IBM details here. All right, so this is the part where I need you guys to start doing stuff and let me know how it goes. You know, at some versions of the class, we provide a VM for people to work in, but I have to rely on you to install Git on Linux or Mac or Windows. I primarily use Linux and Mac myself, so I can't help with the Windows choices very much. So I've got a list of stuff that people have suggested to me. I'm not sure how much to wait here. So hopefully we don't get, let me know if I'm getting too far ahead, and I'll slow down.
Is anyone following along with Morgan? Can you say yes in the chat if you are following along? Okay,
All right.
so some are. And are you keeping
Okay.
up? Oh, quite a few are. Are you keeping up? Listen, okay, some are listening. Is he okay? Those of you who are following along, yes, okay. People are saying that they're keeping up. I'm getting private messages as well as
Super.
public.
Okay. Super. Yeah, I can't check any of that.
Yeah.
I'm
People are good.
mode
People are good. Oh.
Okay. Super. Once you have it installed, you need to set at least the username and the email, because Git will, you try to make a commit, it'll complain at you. Luckily, most of the time when Git complains at you, it tells you what it needs you to do, and it'll say something like, do git config global username to set your username, because your username is unset. So it does try to help you along at times. Mine is obviously already set up, so I'm not gonna, I can demonstrate this if people really want to see it, but it is simple as typing what you see at the screen here. Hopefully this is sort of copy and pastable from the slides, but you don't have to, if you don't have an IBM email address, you can put your normal email address. This is obviously somewhat an IBM focused slide deck, but Git is not an IBM project, so. I can do the git config list things. Let's see. And you can see, you know, I'm using my IBM email address, and I've got my name, and I don't know what all of this other stuff is, but you can see somewhere here I've got GitHub users, my GitHub username. But it is, these are basically just some recommendations I've got in terms of the editor. If you don't know how to use VI, and you get stuck in it, Nano is usually a very simple editor that's also provided. If you're on Windows or you're in a graphical environment, there are ways to set the editor to pop up a graphical window for you.
Morgan, sorry to interrupt. We can't see your terminal.
Can't see my.
We can only see the presentation. We can't see anything else if you're showing.
Oh, you didn't see the.
You need to share with Zoom, I think.
Oh. Oh, this is gonna get troublesome. Share. I don't want to share sound. What if I do? I should be doing the desktop. How about if I exit out of the full screen? Can you see that now?
That works. Yeah, that works.
That's good.
Okay. I'll have to remember to go in and out, I guess.
And someone is suggesting in Zoom share your full. Oh yeah. Anyway, what you did just now was excellent.
Yeah, it's okay. I'll have to be doing that then. That's all. GitHub obviously has a opinionated way to set up Git, and please go to that if you have issues. This is IBM specific stuff, so if you're an IBMer, please check this at the end, and get your user mapped. I do suggest everybody, if you have the opportunity, to set up two-factor authentication, just because once you have a certain amount of power over projects, it's kind of enforced. But it's also just a good idea in terms of account security. I'll leave everybody else who has their own companies to follow their own company rules. But this is the point at which I want you to go to github.com and let's do exit and do sign up for an account. So hopefully you can see this page. I already have an account. I'm not going to sign up, but it is, I'm told, quick and simple still. And so username, email, password, go through, sign in. Let me know if I'm going too fast. But at the end, you should get a let me move this bar. You should get a website sort of that has your account. And so that is your username that you picked. And so that is how everybody is going to refer to you in the future. So make sure you pick a something you're going to be happy with.
We lost your voice, Morgan, if you're speaking.
Oh no, shoot.
We can hear
I'm sorry.
you. We can hear you. We can hear you now.
Okay,
When
okay.
you said shoot, we heard you.
Okay, does everybody make a GitHub account? Did I get that through?
Yeah, you did. Yes, and people are saying yes in the chat. People are keeping
Okay.
up with you. People are making their GitHub accounts who don't have them.
Whew. Sorry. There's an old version of my GitHub account. So at this point, we can go a couple different ways, but I've focused this on going one specific way, and that is to use this API key access. If you guys, if you are familiar with SSH, I would suggest going through and doing an SSH key. It can be difficult on Windows, so that's why I'm not doing it that way. But we need to set up an API key for accessing the GitHub servers from our local machine, or if you know your machine in the cloud, I guess if you have a cloud VM. There are various ways to do this by caching directly the password, but we need to get a special. If you have two-factor authentication enabled, you can't use the password, and so I'm just going through the flow of, well, here's how you get the special password to access your account when you've done that. And I'm going to be using my sort of stunt repository to do stuff. And you can see that the normal, if I go to it in
There's no voice now.
Yeah.
Oh, okay, sorry. I know what I'm doing. When I move this bar, I'm clicking the mute button. Sorry. Two-factor authentication requires using an API token. So if you can copy, you can either copy this and paste it into the browser. I'll show you how to get to the field that we want. Please, nobody hack me. But you gotta go to your user, which is in this upper right-hand corner. You click Settings. Brings up this giant profile page. You go to the lower left of the column on the left. Go to the bottom, hit Developer. Then again, you get into developer settings, and then on another column on the left, you hit personal access tokens. And then what we want to do is we want to generate a new token. And so I will do HTTP. You can name it whatever you want, and this is basically just a note so that you remember what it is in the future. I don't want that one. I want, actually that is the one I want. And so we're going to make a repo. It's very important to protect this because it is sensitive information, and it will allow people to basically do whatever it says here. And this is, access repositories. And so you're going to hit generate, and it's going to say, make sure to keep a copy of this because you're not going to be able to see it again. So I'm going to copy mine and make it go away. But you want to save a copy of that, information, and hold on to it, and then either in the future make another one for different repositories, or to learn how to use one of the alternative methods, which I talked about, the SSH. So now that we have that, oh, I guess I did only need to make public repo. Oops, let's try that. Let me delete that one. Delete. But you can see that this is a very simple process to create new ones. And so once you have that, you want to save it because we're going to need this to access it. And this is the format that we're going to paste it in when we do our clone. But first, before you do that, you have to, whenever you're interacting with a project, so in the future, I suppose you're going to go to github.com Kubeflow project, you're going to have to create a fork of that, and that is sort of creating a clone in the cloud, a different repository in the cloud that you have full access to because it's yours. And so what I want you to do is go to my GitHub sandbox repository, github.com, mhbauer, git sandbox, and then click this fork button, at the end of which you'll end up in a new place that has your username in the location.
So you want people to do this now?
If they want to participate, yes.
Yep. Okay.
Because I have full access to this, and
Right.
so they can.
So will you
click
be able
fork.
to see when they've done it? Will you be able to see them? Yep.
This number will go from 0 to not 0.
Okay, good. All right. Let's look for it going down 0.
Obviously, I can't fork it because it's my own thing. I can fork it to some of these other organizations I have access to. So I'm just going to be doing a direct checkout when I do this. But once you have it, we're going to clone, and like I said, save that password so that you can run this clone command and replace it with your username and folder, username and password. And oops, oh no, I'm gonna have to generate another token. 1 second. Sorry. Move. I don't know if everybody can see the Zoom menu, but it's enormous on my screen.
No, we
Oh,
don't.
look.
We don't see it. We don't
Okay,
see
good.
it. You know, we just see your
yep.
screen.
Morgan.
Okay. Yes.
Would you mind explaining why we have to create a token in order to clone the repo? It's a public-facing repo. Can't we just clone it regardless?
Because if you set up two-factor, you'll have to do this. If you haven't set up two-factor, you have to input your credentials another way. And cloning is not the only sort of, you probably, with HTTP, you probably can clone it without having permissions, but I'm going to want you to push back up to the fork in a bit so that you can make a PR.
Mhm.
And that requires permissions to authenticate who you are so that you're allowed to push to your fork. I'm allowed to push to my fork. You're allowed to push to your fork. And if we don't have, and I don't want you typing your password every 8 seconds, because that's what happens when you do a push. It'll ask you a couple of times. So it's good to do one of the setups, whether it is using the credential helper from the operating system or using SSH. It's good to have sort of an automated way to authenticate with the server. And so that's what I'm trying to get everybody to do it consistently. I know this is a lot easier to set up directly right now using an API token than it is anything else on all 3 operating systems.
Cool, thank you.
So we have the clone information, and so I want once you've got your fork, I want you to clone your specific fork, not mine. And I want you to clone your fork with your username and your password. And we will deal with adding my fork as an upstream to yours at a later section. And you're going to want to do that because I'm going to make changes. But it should look something like that. And you can see, yes, I just did it. It looks something like that. And now we have a new folder, which we can go into and see that there are files. And you can look at the files and run the files if you want. But what did we just do? We just made a local repository and by making a copy of the remote repository. And the remote repository that you should have copied would have been your fork and not my upstream copy. But you can look into the remote the local repository and see all of the versions. Let's do that real quick. If I do git log, you can see that there's 2 commits. There's initial commit, and then there's me adding a base program. You can do the same thing on GitHub, and you click, let's see, where's commits? You click commits here. You can see that we've got the same information, initial commit with the specific information on the new program, and you can see that they both have the same SHA-ish, and that's important because when you're talking with somebody else, a lot of times you'll be thinking you have the same version of something, and you don't. And so it's always good to check, well, what version are you on? What branch, what commit are you on? And I'm on 68C7586. And if you type git log and you look at what commit it is, you should all have the same 68C7586 commit that I have. And so that's where we get this interesting sort of distributed nature where everybody's got the same references to the same files set up in exactly the same way. And then once we sync up again at the end, we'll all still have the same stuff. But until we do that, we have all our own stuff that we can do work against and not worry about interfering with anybody else. And so that's really sort of the great ease here. Is you can't hurt my system. I can't hurt your system. It's all distributed. It's all unique and spread out. But right now, we should have all the same history, all the same branches, all the same commits made by only me, because it's my test repository for this. Sorry. So
do you want to check if people are keeping up? Are people up?
Yeah,
Keeping up?
sure. Hopefully,
Yeah.
hopefully we've all got a clone. And then the next stage here is to go through the workflow. I would like you guys to participate and try to make a commit and push it up. But you know, oh, there we go. You can see 12. There are at least 12 people participating. 13.
Awesome.
You can see, let's see, network. If I go here, this is some of the stuff that I was telling you about earlier, where Git shows you all of the information about your project. So thank you. Thank you for participating, and hopefully we're learning something. Anyway, you've got Git, you've got a repository. How do we play with it? What does my day-to-day look like? At least for me, my workflow is, I got to go find something to work on. You know, if I'm not working on something from yesterday, I got to go find something to work on. Got to make sure all my code is up to date, and then I've got to start doing my work. At which point I'll create a branch, do the actual work, make a commit. When it's ready and I feel people are ready to review it, I'll push it up, make a PR. I'll get lots of reviews, both automated and human, for what needs to be changed. So, you know, if it fails the tests, I need to figure out why it's failing the test and fix that. If somebody doesn't like the way I did something, or they need a code comment, they can tell me, and you'll have the chance to do that in a minute. Then, you know, I'll circle there for a bit. You know, make changes, push, make changes, push, make changes, get review. Eventually, hopefully anyway, the PR gets merged, and I start the process over by going back to the main branch and deleting my work branch, because I don't need it anymore. But again, branches are very cheap, so you can sort of do work in a branch and go on quite a ways before you say, you know what, I don't need that. Let me go back to what everybody else is looking at. So back up a second. Once you did the clone, and I don't know what it is on Windows, but ls, you want to look at your directory, you should see, okay, you cloned the Git sandbox, it ended up in Git sandbox. That's primarily how you'll interact with doing a clone. Is it'll be the last part of the clone will become the directory that exists. There's a flag to Git when you clone it to check out, you know, into a different folder name, as well as to check out a specific version. It's good to know about those things if you're running CI, but for the most part, it's pretty useless knowledge on a day-to-day basis. So I want you to cd in there and ls, and so cd is change directory. On Windows, it might be chdir, I think, chdir. And I don't know what ls is. It might be, I think it's dir, dir. But on Unixes, it's cd and ls. So please go look at the folder directory and the files, because that is what you're going to be interacting with when you're interacting with Git and with source control. Lots of files. Again, if I do git status, you know, this git status. I run this command a lot, and it cannot be overstated how useful it is to get sort of the current status of the repository, and it'll tell you all sorts of useful information. Not only when you're not doing something, but once we start making changes, it'll have lots of information in here. You can see it tells me what branch I'm on, and it tells me, as far as it knows, that it is up to date with the remote origin branch. And you can see that we have nothing, no changes. So it says nothing to commit, working tree clean. It's not a particularly transparent message beyond the nothing to commit part, but it means we don't have any changes that that are available. And so again, this is a thing that I think isn't focused enough on, but it is a very good, like, you can't hurt. This doesn't cause anything to happen other than it looks at the file, so you should be running git status a lot just to understand where we are. So as it says, current state of the repository on disk. If there's changes to files, show the changes. It tells you whether they're tracked or untracked, which basically means whether it's a new file that Git doesn't know about or it's an old file that Git already knew about, whether they're modified or unmodified, etc. So at this point, let me think. I need to move a little faster maybe, but this is, you know, if you were to make a file called file with contents, you know, that's what's going to be. You can see that you can look at it in 2 different ways. So let's go through this. Let's go through this real quick. So if I create a file, touch just creates a file. So you can see there's a new file here, and if I do git status, it says, I don't know about this file. And so you can do git add, and this works with files that also have information already tracked about them. So if I add the file, we do git add, you can see that, yes, it thinks it's a new file. Excellent. So if I add some information into the file and then go git status again, you can see that we're in this sort of half knowledge state. And if we do git add again, we're back to changes ready to be committed, the new file. And so it's good to play around with this once you're right now in the, you know, in a way where in a place where it doesn't matter, to get a feel for it. If I do change an existing file, you can see that existing files also, again, changes not staged for commit, but it tells me it's, you know, in red with the word modified. Okay, this has been changed, and you do the same thing to move it. Same thing to move it from unstaged to stage. Do git add. And you can see that, yes, this is a file that's been modified, so it was an existing file that Git already knew about, as well as a new file that Git didn't know about, that we're ready to commit. But we don't want to commit here because we're working on the master main branch, and we want to commit somewhere else. And so this requires us to make a branch, and branches, again, are cheap and fast. And you can look at all of your, you know, local branches. You can look at the remote branches. And then, most importantly, we can create a branch. And, you know, you can do this in one step with the git checkout -b, or you can do it in 2 steps by making a branch and then checking that branch out. So let's do that then, because like I said, branches are cheap. You should be working on a branch. Don't commit to master. If you do happen to commit to the main branch, we can recover from that. And hopefully I have time to show that. But so let's get branch, show all the branches I have. You can see I only have the main branch right now. I might have some extra ones on the remote, and I do. I've got conflict and squash branch. Clearly I've used this repo a couple of times, but let's do git checkout. committed. And then we will make some PRs in a second. My internet connection is unstable. That's not good. Am I still here?
Yes, you're still here.
Okay, are people making changes to files on branches?
Let's see if they say yes or no in the chat. Are people making changes? Yes, yes. People are saying
Okay.
yes.
Let's see, I covered this slide. I covered that slide. I did this in the terminal. Hopefully you're doing this in the terminal as well. I did this. So yeah, so if you have a file that is has changes, first of all, you can see what the changes are if they're not cached. Let me see, what is this? What is the cached? I think that's the thing. So you can see with git diff, it'll show you what is unstaged unless you say git diff cached, and then it'll show you what's been staged. And staging, again, is just is where you take your file and it's ready to be committed. Ooh, no, 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 touchscreen, don't do that. Undo. Okay. And once you're ready to commit and you do your commit, everything moves to unmodified because you committed it and you said, yes, save this for me. So git, I think yeah, you can reset. There's also this restore command. This is very, very new. A lot of you might not even have it on your version of Git that's available. So the standard way of doing this before that existed was reset the file. And if you do that, you can see that the file goes back to being untracked because it's not a file that I had information in before. It's not a file I had information about before. Example. So now we've reached the point where we're going to make a commit. And so the commit will make a change to everything that you've added. And so let's do that. And so this is going to drop me into a buffer, and it's hard to take screenshots of it, but it will open up your editor as configured, and there will be some diagnostic information to help you understand what you're doing. So type git space commit, hit enter, and you can see that we're in this buffer. Pound sign will be ignored, and an empty message aborts the commit. So let's just exit out right now, and you can see that. Oops. Oh yeah, aborting commit due to empty message. So Git's pretty helpful in terms of making sure that you don't mess something up. And it tells you sort of what it wants you to do. So now that we're here, we can add our message, say hello to the class, and at some point I have a long diatribe on what your commit message should be formatted like. Yep, here it is. So again, this is just plain text. So most projects have some rule about this. I don't know what Kubeflow's rule is, but in general, the rules are pretty simple. It's you have a short single line description, you skip a space, you skip a line, and then you have descriptive lines that describe what and why you're doing what you're doing. In the world of pull requests, the information oftentimes gets put into the pull request text and not the commit text. And this makes the commit history less useful. So I would vastly prefer, if I'm working with you, that you put your description into the commit text and update it as we go along over putting it into the PR text, which is disconnected from Git and the Git information. But you'll see the PR text in a second.
So a couple of questions, one in the chat, Morgan.
Yeah.
Someone's asking if you follow a branch naming convention.
I don't. If I'm working, like, it's almost nobody will see this branch name and care about it. We'll see it in a second when you make the PR, but a lot of the times people just use their name. They'll say, yes, it's Morgan's update to file, right? Or it's one of the ones that I'll use a lot is like if there's an existing issue, I'll say, issue 2345, right? And so I know, okay, well, that's where I'm working on issue 2345. But beyond that, there's I don't know of any actual restrictions on branch names other than, people can see them, so don't curse in them, I guess. It is all just text.
And another question for me is I've made your slides public because they
Yep.
weren't.
Yep.
Are you okay with that?
Yeah, there shouldn't be anything in here that's, there's some IBM specific stuff, so I'm going to have to make a new version or something, but we'll
okay,
figure that
but
out later.
so people can access the file now. I've given them a link, so because in the agenda it's not public, the link, so I've given people a public link.
Oh, okay, yeah, no, that should all be fine.
Good. Okay,
Just a time check, Morgan.
Yep.
I believe we are probably 5 minutes to 9:30, right? So
Yeah, no, I just want to get through making the PR and then we can stop. I'll have to avoid the diagnostic and sort of debugging stuff. You save your commit message. It writes it to disk. Oh, I don't want to do that. Oops. Give me 1 second. Let me just. Oh no. Commit text. Do 1 second. Okay, so we made the commit, we saved it, and I did some stuff that doesn't matter. But if you do git log, you should see now we have a new commit on top, and my commit is terrible looking, but it is there. At which point we want to push up the changes. And so you have set your fork up, and so you need to push up to your fork. So you need to know your branch name and you need to know your remote name, but the default remote when you check out is origin. If we look at the remotes, you can see there's the remote. And my branch name is this. And you can see we do the push and it detects how many objects there are and it does a bunch of stuff. GitHub now prints out this very nice message that says, create a pull request by visiting. And so you can actually just click that guy right there and it'll go to the place online. Boop. But if you didn't want to do that and you're not using the hub command, once we're here, we can see, okay, I've got a new branch and I can create a pull request. And so what I want you guys to do is to do that push, to make the commit, save it, do the push, and then make the pull request. So I'm going to make my pull request with my really bad message. And hopefully, oh no, I don't think I have CI enabled on here anymore. Anyway, basically, oh no, it looks like it's doing something. Yeah, there we go. So I just want to demonstrate to you that if you make a change, a lot of times there's going to be some automated tooling that comes along and says, does this build? And it will check the program. And in the end, oh no, it didn't build. It did not like my change. Oops. Yes, because I changed the text. So it's good. That's exactly what I want to have happen. Let me go back to the slides. If you make a change and then you need to re-push it, so I need to change my test. And you should be running your tests anyway. You can add new commits on top and push them up to fix your tests. And eventually, make a pull request. Somebody somebody could ask for changes. Anybody having success making a pull request? And I know I'm getting very over the time, so.
Yeah, I don't see any responses. I'm going to help someone find the Kubeflow Dojo channel. I'll just do that now. But anybody successful?
Anyway,
Yeah,
I don't want to
we
intrude
have
into the
some.
next.
Yep. There are a few yeses coming. Yep.
Okay. There we go. Thank you, S.R. Meyer, Stephen Meyer. Thank you very much. So this is great. So I just want to demonstrate real quick. Somebody will leave a comment. Excellent. Thanks for the test. You can do a review, at which point you can finish the review and say, this looks good. Somebody will approve it. Eventually, you'll have the power to do this yourself on repos that you belong to. And you can say, you can see, look, it's reviewed. It's got a green check mark. You can see that the build, well, when it finally does, it'll be green. You can see I have it turned on so that I'm not allowed to merge it if it's not, if it doesn't successfully pass CI. So, oops. Yay, excellent. Okay, so lots of people making PRs. I have to finish up here, but somebody may ask you to make a change, or somebody's change might get merged underneath you. And this is all covered in the slides on how to resolve your merge conflicts and update your remote. But I don't want to go over too long. So, Animesh, do you want to have the next person take over?
Thanks, Morgan. I think that